Hello everyone and welcome back. This is going to be part 2 of the basic arithmetic operators. We're going to continue on where we left off from part 1. I'll go ahead and link that in the description. If you haven't seen part 1, I would recommend you watch part 1 before you come and watch part 2 so you can get a basic understanding of what we're trying to solve here with this C puzzle. So with that, let's go ahead and jump right in and actually solve the next statement. Operators 1.3. So here we have the statement x is equal to minus 3 times 4, percent sign, minus 6, backslash 5. We go ahead and print out the value of x. So in the above statement we have 5 operators. We have the equal sign, which is the assignment, the minus sign, which is going to be used for the subtractive, or the negative sign, or the unary, depending upon the circumstance of where the minus sign is in the expression. We'll have the asterisk, which will be defined by the multiplicative operator, the percent sign for the modulo operation, and the backslash for division. So out of these 5 operators, which do we evaluate first? The one with the highest precedence. So in this case, the one with the highest precedence would be the unary operator, which will go ahead and bind the minus sign to the 3 and enclose in parentheses, as well as bind 6 with the minus sign and close parentheses. And the reason why we go ahead and bind these two numbers is because there is no other operand in front of the minus sign, which will make that a subtractive operation. The same thing comes with the 6. There is no other number here that would make this minus sign a subtractive. Therefore, we go ahead and just bind those two numbers to the negative, or in this case, the negativity operation with the minus sign here. Following this, we're going to jump into the next operator that has the highest precedence. In this case, it would be a 3-way tie between the multiplication, the modulo operator, and the division, since they both have the same level of precedence. In order to actually continue on with this, we'll then use the associativity, which is defined from left to right. I can go ahead and confirm that by jumping into our operator precedence table. So you can see here in the third row right here, we have the multiplication, division, and modulo, and the associativity would be from left to right. So starting from the equal sign, we're going to go from left to right, and the first operator we encounter will be the next one we evaluate. So as you can see here, we encounter the multiplication sign first, so that we'll go ahead and enclose in brackets negative 3 times 4. Continuing the same process, we encounter the modulo operator next, and last but not least, we'll encounter the division. So after doing this multiplication here, we're going to go and see that the result of this multiplication would be one operand to the modulo operator, with the other operand being the minus 6. We'll go ahead and close that in parentheses, and the result of this whole expression would be one operand to the division, with 5 being the other. Go ahead and multiply negative 3 by 4, we get a negative 12. We'll compute the modulo operator here. Negative 12 divided by negative 6 will give us a value of 2 with a remainder of 0. Therefore, the result of this modulo operation would be the result 0. As you recall, the modulo operator will give us, or the result would be the remainder of the division between your two operands. In this case, our remainder was 0, therefore the result will be 0. We'll then divide 0 by 5, get a value of 0, and we'll last but not least assign the value of 0 into x, once again using the assignment operator here, which has the lowest precedence among the other operators we saw in this statement here. And then we'll go ahead and print the value of x, which would be 0. Operators 1.4. So here we have the statement x is equal to parentheses 7 plus 6, close parentheses, percent sign 5, backslash 2, and then we go ahead and print the value of x. So of these 5 operators we have in the above statement, once again we have the assignment by the equal sign, we have parentheses, which really is not an operation, but we'll see here shortly that the parentheses does have a say in terms of precedence when you try to evaluate certain operations. We have the plus for the addition, the percent sign for the modulo as we saw in the previous examples, and the backslash for division. So once again, which operator has the highest precedence? Well, in this case it would be the parentheses. So anything inside the parentheses will be evaluated first. So the addition of 7 plus 6 would be evaluated first. The second highest precedence operator would be a tie between the modulo operator and the division, as we can go ahead and confirm by looking at our operator precedence table. We see that the backslash, the division, and the modulo operator are on the same level of precedence. Therefore, the associativity will be from left to right. So starting from the equal sign, we're going to move to the right, and we encounter the modulo operator first. So we go ahead and enclose the addition of 7 plus 6, which would be one operand to the modulo operator, with a 5 being the other. The result will go ahead and be enclosed in parentheses, and this value will then be one operand into the division operator, with 2 being the other. We'll go ahead and add 7 plus 6, which will give us 13. Go ahead and compute the operation of 13 mod 5, which is the vernacular in terms of programming languages. So 13 mod 5 will give us a remainder of 3, because when we divide 13 by 5, we get a value of 2 with a remainder of 3. We'll then divide 3 by 2, and lastly assign that to the value of x. But we have to consider here a special case. So when we divide 3 by 2, our value, or the result here, would be 1.5, which is known as a floating point number in programming languages. But because we were assigning 1.5 into x, which is an integer variable, that is not possible due to the fact that we have this extra decimal point here. So what will happen is the compiler will go ahead and truncate or round down the value of 1.5 to the lowest nearest integer, which in this case will be 1, and then go ahead and assign the value of 1 to the variable x, because 1 itself is an integer and x itself is an integer variable. Therefore, we can assign an integer value into an integer variable likewise. So in this case, it's important to note that in certain circumstances, some values like 1.5 cannot be assigned into a different type of variable. We must assign the same type of variable or the same type of value into the same type of variable. Otherwise, we're going to get some sort of truncation or different side effects, as we'll see in the future videos, and how different values get truncated and so forth. And last but not least, we'll go ahead and print the value of x being 1. We'll go ahead and confirm this by actually trying to run the program. I've already compiled the program here, and I've named it operators1, so I'm going to go ahead and run the object file here, and we'll go ahead and see we get the results of 11, 1, 0, 1, which you can go ahead and confirm by watching part 1 and in this video that we do get the expected results by solving these puzzles. So the next puzzle we're going to go ahead and tackle is operators 2, assignment operators, and that'll be coming here soon. So thank you all for watching, and stay tuned for this next puzzle.